We're going to take a look at an intramolecular variant of the Fischer esterification. And most of the reactions we've been talking about are intermolecular, meaning the two things come together to react. So for the Fischer esterification, it's the carboxylic acid and the alcohol coming together. When you're talking about intramolecular, that means both reactive components are in the same molecule. So that means our carboxylic acid and alcohol are going to be tied together into the same starting material. So this reaction is going to form cyclic esters, which we call lactones. So let's take a look at an example of this. And we'll say here's our carboxylic acid. But then on down the chain, we have an alcohol. And let's use an acid. You could use sulfuric or phosphoric, just a strong non-nucleophilic acid. And just like we talked about in the last case, the net result is going to be the hydrogen from the alcohol, the OH from the carboxylic acid, going away as water. And then this oxygen will bond to the carbonyl carbon. And a lot of times with these intramolecular reactions, it's really helpful to number things. So I'll number the O as 1, go down the chain. So that's bonding to the carbonyl, which is 6. So that's going to give us a 6-membered ring. So here's what that would look like. There's 1, 2, 3, 4, 5, and 6. And your byproduct is water. So this product is a cyclic ester, which we call a lactone. But specifically, this one is referred to as a delta lactone. Now, how do we get that? What you want to do is basically count your carbons until you run out. So here's your carbonyl carbon. Then we have an alpha carbon, beta, gamma, delta. Now we're out of carbons, we run into the oxygen. So that's how we get the delta lactone. If you just had say a 4-membered ring, here's your carbonyl carbon, the carbon next to it is alpha, then we have a beta. So this would be a beta lactone. Now, although this reaction isn't used to form amides, just in terms of nomenclature, this is a good place to talk about cyclic amides as well. And a cyclic amide is called a lactam. So let's say you have this cyclic amide. Just like we did with the ester, there's your alpha, beta, gamma carbon. So this would be called a gamma lactam. If you want to practice the mechanism for this, it's exactly what we did with the intermolecular version, all the same steps, except instead of using an external alcohol, your alcohol is already right here on the molecule, but it's going to be the same process. You'll protonate the carbonyl, use the lone pair on the alcohol to add to the activated carbonyl, and then just follow the steps.